um, gone through yesterday's session regarding the application of AI and reservoir engineering. So we have gone through one of the most important topic, that is inflow performance relationship for oil well as well as gas well. So oil well we have created in Excel, as well as we have done that job in Python without copy the code from the chat GPT and paste it in the Python environment, and we got the result. And we have created and another topic is that is gas inflow performance relation. That is actually to say it is not uh, a common or linear one. It is something complicated. uh, Even Excel, we need to use AI to get the simulated results. So certain times, like certain platforms, they need some libraries to get installed. Then only we can able to get the result. And this is a kind of simulation. If you could observe yesterday's session, I think it's already available in recorded videos are there in the YouTube. You have seen that we have simulated the value of A. Just I'm going to take you to the um, yesterday's uh, Excel sheet. So this is the Excel sheet that we have done. So here what we have done is, so this is the data that we have, like PWF, which represents wellbore pressure, PR square minus PW square, that represents your LHS on this equation, and RHS we created with the data that we have. And this is the constant values A and B you are seeing over here. And this is the simulated results that we have generated through AI in solver function in Excel. So solver is also a part of AI tool that it is available in Excel. So you can use that to generate A and B. And these two are constants, and based on that, you are getting a simulated value of this, which is almost equal to your LHS. So we used LHS and RHS and this equation to generate these two constants. Then once after that, what we have done is, we know that the constant is this, and you can give any value at the empty space. With that, it will give you your RHS and LHS. And we used RHS as well as LHS to simulate these values. So these are the two kinds of simulations that we have done yesterday in Excel. So the same thing we will try, if it is possible. We will try to. This is something which is advanced for beginners. Even Python, you need 2 to 3 more libraries, and the coding, how it is going to adjust among itself, we are not sure about that. Like we will make this happen with chat GPT, and we will see how the outcomes will come. Actually, the thing is like how you prompt it. Like it depends on asking the question, like how you are going to make. Right now, whether if you understand, probably chat GPT will understand. If you're not understanding it, probably I am failed to make you to understand. That means my prompt is wrong. So in the same way, if you ask chat GPT wrong prompts, then definitely it will not, accurately, you may not able to get the result. This is what the, you know, uh, constraint that we have with AI. Probably, we need to learn how to prompt it. So let us go and check out. Of course, this is not that easy to prompt it, but still we will try. Why we are not at starting of Python or whatever we are going to do. We are actually going deeper into that, and we will see whether we can get that equation, the things, what the results we got it in Excel, whether we will get it that or not. We will see. AOFP can be determined at PWF, that is equal to 0, and we got the answer around 8,500. Like it could be nearby 8,500. It's not exactly why, because it depends on the kind of decimals that we have taken. So decimals also will uh, give different answers for that. So let us try to go to chat GPT and ask for whatever results that we have generated yesterday through Excel, whether we can get through AI. So for that, what I have taken is for convenient, I have taken the given data. I kept it on the other side of the Excel sheet to just copy and paste in the chat GPT rather than I have to pick somewhere inside here. So it could be difficult. So I'm just copying the data over there and I am going to chat GPT. This is the new window. So this I'm just copy and pasting the data. So you can see the data was pasted here. I'm just removing the suffixes so that my prompt will be easier rather than I have to always type that suffix again and again. So right now in the prompt chat box, I have just kept the data from the Excel sheet. So it was Q on the one column and P is on the other column. But we need to define what are these things to make AI to understand. Q before defining this, what I would like to do is, you already know that the method we are following is pressure square method. Like you can see the method that we are following is pressure square. So you can see PR square minus PW square is equal to A into QG plus B into QG square. So what I will do is in place of uh, QG, I am taking Q. So I'm just replacing it with Q so that prompt will be easier and remaining things will be as it is. So just let me try to keep that as it is. First of all, I'm going to fit this data in that equation. So I will ask it to fit the data in the equation P R power 2 minus P power 2. So whatever I am writing here, this equation, actually it is in the form of MS Excel. So that is the reason you need to have some awareness of Excel. So power, we are not going to use any other than the symbol that I'm using over here. So if you know how to use power, you have to use this. But when it comes to Python, you are going to use double star. So asterisk, like you need to do two times. For power, two times you have to type asterisk. So here we are going to use this particular symbol for square is equal to this is like Excel. So if you have idea on Excel, it will be good. A into capital Q plus B into capital Q square. This is the equation that we are fitting the data in it. So the P values will be in here and PR is constant. So that we are supposed to define it, comma, PR is equal to the first value of it, that is 1952. So I'm just giving that value so that it will be easier to understand that the PR, wherever it measures, that will be constant. So we asked this data to fit in this equation and we are making PR as constant. And again, A and B are also constant. So this A and B, for every iteration, these A and B represents constant. So let me define that also. A and B are constants. And right now, what is our objective? Objective is to define A and B. So we need to estimate the value of A and B so that my RHS, if I put the value of Qs in RHS, the LHS value also will become similar. So both sides, the value will be same if I define A and B that are also supposed to be constant. That should not change. Like, you know, for the first value is different, second value is different. That should not be the case. So all the values of A for all the equations on RHS must be equal. So A and B are constants on RHS side. When it comes to LHS side, that values were already defined over there. So this is actually the one which I am asking AI to, keep all the constraints based on that, provide me the result. That is what I am going to do that. So next thing is I'm going to ask it to define the values of A and B. So here we should not ask like define. Why? Because we have a technical term for that. Why? Because we are not actually defining it, but we are probabilistically, we are estimating the value of A and B, which is supposed to be constant. So the term what we are going to use is optimize. optimize. Actually, this optimized value is a function of Python. So if you would have an idea on that, it will optimize all the values to give you the best fit for a curve or for an equation. Right now, our condition is our RHS must be equal to LHS. So optimize the values of A and B. That is one condition. And what is the final condition? What is the last condition that we are going to see is whatever value that have been given to A or B, this RHS must be equal to LHS. So that is the condition I'm going to do. RHS, simply I will write RHS is equal to LHS. So A, whenever it sees RHS, that's a short form of right hand side. So it knows it. A already know that. And when it says right hand side, it knows that there could be an equation in the prompt. So it will go to that equation. From there itself, it will redirect it to the form of that equation, that is A into Q plus B into Q whole square. So no need to type everything, just give RHS is equal to LHS. So that condition have been completed. And right now what I'm going to ask is provide me a code in Python single or one, or else I can write nearby one code in Python. Like I'm asking it to give me full code in one frame. That is what exactly. You can just type like that. Provide me a code with full, one frame itself or single cell or anything you can ask. Just for, I have asked it to give me in one code Python. And right now, what is the outcome I'm expecting is the value of A and B. So it need to start iterating the values, whatever conditions that we are given. So A will start, giving the code to fulfill all the conditions that we have given. And finally, I have to get an outcome. And definitely, this outcome could not be accurate. Why? Because at instance, AI will not give you right result. So only thing is we need to see what outcome it is giving. Based on that, we need to understand and we need to do some alterations, or, if your question is correct, you have to ask it once again. So this is what exactly we're going to do. Okay, let us see. And you know already the values of A and B that we have defined it. So whatever values we get from here, we know whether it is right or wrong. So in that way, we can able to see how AI will provide us that outcomes. So I'm going to give enter so to get the code of that. So it used two libraries. One is NumPy, another one is SciPy Optimize. So this is actually curve fit data that they have been used. So it has taken that library to use this data. So it is optimizing the values of A and B. You can see at the last, it is given print optimized values of A and optimized values of B. So let us see what could be the result of that. So this is Google Colab Python. I have pasted the code and shift enter. It's taking a bit time. So since it is, so I got the values of A as minus 0.953 and B as 0.0001333. So actually we don't know whether this optimized values are right or wrong. So if you go to Excel sheet, I'm going to show you that values. So this A value is positive and it is 307. If it is coming close to 300, 330, 320, 370, we can accept it. And B value is 0.01. So here we got a different value when it is compared. So this is what happens whenever you give one. Of course, the code might be right, but analysis could be somewhere. It depends on how you have adjusted it. But if you start doing each and everything from point 1, 2, 3, 4, then you will get the answer. But this is something that directly we are asking it so that it is giving you one kind of solution. But let us ask it once again. Like, let us think that if our code is right. So what I'm going to do is I'm going to keep the same prompt and I will ask once again. Let us see whether I will get same value or not. So this is the option to edit the code. prompt, just click on it. So you can do editing, but I don't want to edit anything. Why? Because the prompt what I have given, that is what exactly I wanted to do it. So let me go and ask once again. So let us go ahead with the thing. So it has given another form of code. So let me just copy it, and I will keep the same code at the top. Shift enter. So this has given some other values like A is equal to 1, B is equal to 1, of course. So fitted values, which is not, which is not in our own domain. So what I will do is I will go to chat GPT. I will ask an alternate solution for that. Alternate. Simply I will write alternate. So just click on enter. Let us see what we have. So it has given a code. Let me go for it and paste it, enter it. So it has given some values. There is no A and B actually here. So this is not exactly that we are expecting. So you can see fitted P is there, but there is no optimized A and B in this code. So for that, what I have to do is just again, I have to edit it, click it, go once again. So this is the kind of things that why, because we are asking it something to do like multiple operations it was supposed to do. So obviously it will take different simulations. So at one simulation itself, we cannot get exact result. Yes, finally, I have done once again the operation, but you can see the values over here, A and B. Just I'm copying it. I'm going to check out the value in Excel. You can see, you can just observe the values of A and B here. Yes. So 307 is A value. So here we got it 319.9. Okay, that is somewhat close to it. Why? Because it has given large decimal values. And B value is also 0.016. It was given as 0.012. So you have asked actually right prompt, but it has taken 3 to 4 iterations to give you the exact answer that you are expecting. So this is what exactly happens with AI. It could be like you can define even more and more, but the thing is like you can reduce the time by asking repeated to get your own value. Okay, so I haven't changed the prompt. If you change it, probably you may get wrong result. So initially I kept the prompt. Only thing is I am getting different results one by one, one by one. You can see that results I have already kept in the Python, this one. So earlier result is something which is not at all uh, in our domain. So when it comes to the earlier one and one optimized. So this is also not under the domain. And when it comes to the first result, that is like minus 0.95 and 0.00013. So it has taken 3 iterations, and finally at the 4th iterations that it has given you the right uh, one which you are expecting for. So this is the first simulation technique that we have done. So we can use the values of A and B to generate AOFP at PWF is equal to 0. For that also the same process we have to go. So let us just quickly get into that and we will see whether we will get AOFP value by that. I'm copying right now these two. Why? Because AI doesn't know the values of A and B. Why? Because in the chat GPT, they never we mentioned about A and B. Even in the code, it has given you actually the code to define A and B value. But if you ask it to use that values and start going forward, it will again start to optimize the values of A and B. Why? Because it doesn't know what is the value of A and B and what is that you are taking. Like, you already got a result, like it has given multiple results, but what solution that you have taken, from that solution you are going forward. So for that, you have to redirect that solution from whatever you got it from the environment, and you have to paste it in the chat GPT in the next prompt itself. Why? Because you cannot open the new chat box, only the one, whatever the page you have continued, So I am going to put that. I copied that result, Control V. So first of all, in this chat box, immediately I kept the values of what I am interested of. That is A value and B value. From there itself, what I will do is I'm going to just copy the same thing, but I will just go to Excel, and so here all the values I have. For these values, I need corresponding Q values. So I'm going to put the values of PR square and this one above that. And this value I need to fit in this, again, this equation. But right now I don't need PR, I don't need A and B. Why? Because we already defined that values. So, but you need to fit the data over here. PR square minus P square, which is on your LHS that we kept over here. And you know the value of A and B, that also it will be taking here. But these values are not that given data values. These are the values you are supposed to define the value of Q by using this data. So your LHS values are available here. In RHS, A and B is there, but you don't have the values of Q. So you are supposed to define the values of Q. And the last value is the one where PWF is equal to 0. So the last value, you're going to get the value of Q where PWF is equal to, that can be given as AOFP. So, comma, and right now, again, you need to optimize on. Again, you have to go for optimization, but not for A and B. This time, you are going to optimize the values of Q. Optimize simply Q for each values in RHS. I'm going to just write what are the values are there in RHS, comma. And again, we need to give the condition that RHS must be equal to LHS. Why RHS has to be equal to LHS? Why can't LHS should be equal to RHS? Why? Because whatever value it is giving, that value you are going to plug in RHS. So that RHS must be equal to LHS. So actually, what are the values that we are going to get? That is related to RHS. The condition is here that RHS values must be equal to LHS so that our condition is satisfied and the answer what we are going to get, like optimized answer, that we can be considered. So that is one thing over. And we are going to ask for optimized Q, the optimized Q for each PR square minus P square RHS is equal. Okay, that was over. I want one code in Python. So this is what I'm asking. Let me go ahead with that. So it took A and B values and it took all the values of RHS and it is optimizing the values of Q. Let me just check out. And as I said, I'm not expecting in one iteration. So go ahead with that. And we got the results of yes, I think we got the answer. So it may be a little confusing, but I will ask it to give me in tabular form. Generate in tabular. So it will be easier to identify whatever values are there. So you can see the optimized values of Q. I'm going to put Excel. So you can just cross check with the values what we got it. Yes, see these values. This is what the values I have generated here. So for 2370304, for 2370304, 5874, it has given 5979. Of course, it is close to it. It cannot be exactly the same value. Then next value 260034, it has given this. The answer is in Excel, it is 6328, and we got 6459. So you can see in that way the last value 3810304 and 3810304. The answer is 8500. where AOFP, but here we got it as 8,807. Yes, of course, little bit difference will be there, but that is acceptable. So, this is how we can able to optimize the values of Q. Of course, this is something, you need advanced libraries like SciPy. So if you start learning in Python, regarding to, you can see the library that it has used is NumPy, SciPy to optimize, and it has imported the function minimize. It has imported as minimize, and finally it has used pandas. And it has created pandas to generate the table, and SciPy optimized to estimate the best value, like for that particular queue. It is just giving all the iterations, and the NumPy will calculate all the other calculations. Like we have given the equation PR square minus P square is equal to A into Q plus B into Q square. So that value will be taken by NumPy. So these three libraries it has been used, and it has generated the uh, code like this. So this is how we can able to get the values of optimized values of equation. And if you want to generate a scatter plot, so we can use that also. But for that, what we have to do is, again, we need to take the values over here, and you have to copy in the chat GPT to generate that value. Okay, so in that way we can, but you can directly, do that. If you want, you can copy these values, put it here, generate scatter plot. You copy the code and go to, let us see whether it will generate scatter plot. Yes, it has generated scatter plot, and this is actually gas IPR. So you can just, in place of scatter plot, you can just name it as gas flow performance relationship. So you can get the values of it. But if you really want to change the background, it looks like grid blocks. If you want to avoid that, also we can do. Like we can just change uh, background to be dark, and remove grids. So you can see how these changes have been taken. Like you can, whatever you want to change according to the graph, where Python can do that, also can be possible. So if you want to attach a line, join scatter points with line. So you can see how light have been also attached to all the scatter points. So this is actually IPR, where the optimized values were given, as well as PR square minus P, W square is given, and according to the Python, what is AOFP? That is 8807. So this is how we can able to estimate. I am clear up to here, I believe, and let us get into today's concept, that is production decline curves. So today we are going to discuss about production decline curves, and we are going to see how AI will help you to get some insights by this. So we will continue with production decline curves, and we have three types of curves are there. Like one is exponential, harmonic, and hyperbolic. And the purpose of these curves is to estimate the future production. Actually, it is going to forecast. So oil and gas industry, according to API standards, American Petroleum Institute standard, have given these three curves, and these were fitted into equation, ARPS equation, that is QT is equal to QI by 1 plus B DIT whole power 1 by P. So what is QT is production rate at any time. So Q represents production rate, barrels per day, MSCF per day, or like if it is for gas, it will be standard cubic feet, and if it is for oil, that will be barrel. So T represents any time, any time. It could be of during production time or during injection time, or any time you can take the time of that particular period. That is equal to QI. QI means initial flow rate. Like at the starting of your production, what will be the flow rate? That value is QI. And 1 by 1 plus B DIT means B is an exponent. B values have been given here. For exponential is equal to 0. Harmonic it will be 1, and the hyperbolic it lies in between 0 and 1, which is something that we are not sure. Why? Because hyperbolic is the one which is bit, we need to do more analysis on hyperbolic to understand what is the value of B. And when it comes to DI, it is initial decline rate. That is like initially how much decline rate that is possible, that can be taken as a constant. So B is constant, D is constant, and other parts are all variables. Even QI is constant. So the time is variable, B is constant, D is constant, and QI is constant. So only the one that is variable is time. So if you know the value of time, if you define the values of B, DI, and QI, then you can start forecasting forward. This equation is ARPS equation, but it will change when you apply the values of B as 0, B is equal to 1, and B if it is in between 0 and 1. So let me just give you the real forms of it. So imagine if the graph is there, Q versus T, that is the production decline graph. So you can see the dotted line that represents until that it has been produced, you have the data, past data. After that, you need to predict future. So for that, the red line one, that is the one which you have constructed with the data that you have. So this is the data that we already have. From there, you can construct the three models like hyperbolic, harmonic, and exponential. But the one which is fitting on the red line is harmonic. Of course, it cannot be 100%, but you can see the hyperbolic line and exponential line, which is away from the red line. So that means these two are not the best fits. So you can use the best fit, which is close to your original data. And from that itself, you don't have the data for future, but with that model, with that time period, if you know whatever time you can fix it, that will give you that estimated result of that. So this is how production declines will help. Imagine you have 5 years of production. You want to know what will be my production rate at the end of 7th year. So through harmonic, you can get the value of production rate at the end of 7th year. So this is how the production decline curves will help you to forecast future. There are a number of forecasting methods are there, but these are the proven techniques given by American Petroleum Institute. So we cannot use other forecasting methods to estimate future production of overall process of oil and gas exploitation. So you need to follow this production decline curves to forecast future. It is one of the most successful technique that have been undergoing today. Even it has been done at past, and it is expected to continue in future. So we can see that the other forecasts also there, but that cannot be considered. So this is how the production decline curves looks to be: Q versus T, log Q versus T, Q versus cumulative Q, log Q versus cumulative Q. You have this is how the pattern like of exponential, hyperbolic, and harmonic looks to be. And here also hyperbolic, exponential, and harmonic looks to be. When you change y-axis to be log, and this is how the equations look like. And QS, if you have cumulative production data, the equations looks to be, the curves looks to be like this. Okay. So these are the equations that we are going to adopt to get the values of exponential, harmonic, and hyperbolic. So, you know, b is equal to 0, b is equal to 1, b lies in. So we know the value of b's for all, but we don't know the value of d. So to get the value of d, you're going to use this equation for exponential to define the value of d. So y is equal to mx plus c. This is in the form of a straight line equation. So based all the equations are here, we have to convert that into straight line equations. From that, you need to define the values of b and d. For the first one, there is no need to define b. Why? Because b is equal to 0. Only you need to define the value of d. For the second one also, b value was given as 1 and you are supposed to define only the value of d. But the third one, you need to define two unknowns. One is b and another one is d. Okay. So there is a process to define all these three. And if you have defined it, imagine this is the data. Let us try to think. Time is there. Log Q is there. You can see 413, 365. This is the production flow rate and the time. You can just use a highlighter. So this is the time period, 30 minutes, 60 minutes, 90 minutes, and production values were given here. And based on this data, these have been converted to log Q. So 413, log of 413 will be 2.6. So log values were given. Why we are using log values? To get the value of t. If you could see here, the equation is in the form of logarithms. So that is the reason we are converting that into logs. So once you get into logs, you will be getting the value of t. Once you get the value of t, you will be getting the value of exponential log q, harmonic log q, hyperbolic log q. So these are logarithmic values. But if you anti-log them, you will get the values of, you will be getting in the form of barrels per day in this way. But if these are all the values which are in the form of logs. Okay, so that values were kept over here. You can just anti-log it by making it into 10 power, whatever it is there, power 10. That is what you can, if you use it, you will get the answer for barrels per day. So this is exponential values, harmonic values, hyperbolic values. This is your original value. So Q versus T here, log Q versus T is here. So if you want to put both exponential, harmonic, hyperbolic, you can see there are three curves have been kept on this graph: exponential, harmonic, and hyperbolic. And this is your original graph. So if you, which one is closely related to your original values, that can be defined through slope. So we don't know which one, like whether it is harmonic or hyperbolic or exponential. So which one comes close to your original data? You have two ways to define. One is slope, another one is R square method. So slope means you need to define the slope of your original value, and you will be defining the slope of your modified or experimental value of hyperbolic, harmonic, and exponential. So this Q will be different, T will be same. Why? Because Q was defined through exponential with the constraints of B is equal to 0 and it defined T. So in the same way, harmonic and hyperbolic. So these values are given different slopes. When you observe here, the slope of first value is close to the slope of exponential. So you can consider exponential for this data. In that way, we can consider. But there is another method is there. That is the most taken method for consideration. That is R square method. If R square method, if you use it, if any value like exponential or harmonic or hyperbolic, if the value is above 0.95, then that can be considered. Which value is more, that will be taken into consideration. So let us just get into that. So this is how the equations are. And if you see, this is how production decline curves looks to be. The original values are in this way, blue color. You can see this is the blue color. This is the original values. And the fitted curves are hyperbolic is an orange line, orange curved line, and exponential is the green one. But you can clearly say that the orange one is the one which is almost touching most of the points. Of course, the points will be random. It cannot be exactly in a curved way. So the one which is going to fit the most will be considered for the forecast. So in this example, we can consider hyperbolic could be the one which can be fitted for forecasting. This is an example. So let us just get into our real-time data so that it will be easier to get the values. So I'm going to put production decline curves data. So this is the data, the original data, cumulative production time. We have seen that in minutes, here it is in days, and flow rate is there. So this is original. And we have done all the calculations. So this is a separate process to do, how to do exponential, how to do harmonic way of calculating, and how to do hyperbolic way of calculating that we are not going to discuss in this session. Why? Because uh, this is totally a different area and it takes its own time. So, okay. So let us think that we got the results. We have defined the values of D and D for all as well as B for all. B you already know, but the last one B value you are supposed to define. So I got the value of Q here. That is the original one. And Q for exponential and Q for harmonic and Q for uh, hyperbolic. So let me just try to, let us see how the graphs will fit here. So I'm selecting time and Q. This is the original one. And I'm going to see, I will match with exponential graph. I'm selecting whole column of that. And I'm going to insert. So you can see the one which is blue, I'll change the type, it will be easier to understand. And, yeah. So the one which is this, the blue line is the line and orange one is exponential one. So only very few places it was fitting. The graph, what you are seeing on the screen is the one which is related to exponential. This is the one which is related to exponential. Okay. So if I click on it, so I got the values of time and exponential one. So you can see the fit is not that great. Why? Because only very few points are fitting. So let me just minimize this. I'm going to select the graph. You can see the one which is exponential. I want to shift this to harmonic. I can drag these values to harmonic. So let me check out. So harmonic is fitting better. You can see the values of orange line that right now represents harmonic. It's not exponential. Of course, the value was kept over here. So this also has to be shifted there. So this is the reason. So you can see harmonic fit. So harmonic was fitting better. So let me just, I will drag it to hyperbolic, the one which I have estimated. I will just cross check that one also. Click on this and let hyperbolic values are here. Okay, anyway, yeah, when you see harmonic fit, this is also fitting, but actually harmonic hyperbolic, like right now it is hyperbolic, not harmonic. Hyperbolic is also fitting, harmonic is also fitting, but which one is the right one? That can be defined through R square. So for that R square method in Excel, we have a formula that is equal to RSQ. Why? Because we don't want exponential. Exponential is not fitting. So no need to waste much time on exponential. Just open the asterisk. So RSQ right now for harmonic, it is asking the values of both Qs. So X and Y it will ask, but you can simply take in place of X and Y. We need to see the variations between original Q as well as the harmonic Q. Why? Because these are the things that we are seeing the variations. T is common. So that is I have selected for original values of Q. So you can see in this equation, it was selected original values and it is asking for the second value that is harmonic. So that is here. For that also, I'm going to select up to 53, I think. So I got the value of harmonic RSQ R squared as 0.97. 0.95 above onwards, it is acceptable. 0.97 is a very good match. That means both values are almost like 100%, like 97%, they are matching with each other. So this is for harmonic, but we know that there is a confusion between harmonic and hyperbolic. Whether which one will be the right one? That is what exactly we want. Okay, so we have calculated RSQ for harmonic. Let me calculate for um, hyperbolic. So hyperbolic, take the original values, put comma. So right now I have selected the original values, put comma, and go for the hyperbolic values. Hyperbolic values, select all until you reach the last term. I think this is the last value. Just take it. So I'll just go and see what it. Hyperbolic is showing 0.98, which is more than harmonic. So right now the fit of hyperbolic in this R square method, it will tell you that that is having more better match than harmonic. So according to Excel, the answer is hyperbolic. From that onwards, you can start forecasting forward. Let us go to AI and we will ask, we will try to ask what AI will give the solution. Okay, let us just go to AI and we have the original data and we will see how it can be done. So you may think that these are all the things that we are going to generate. Let us see what we can able to do. Let's see. For that, I need original data. I'm selecting the tabs for all the data from the original values. Control copy and go to, I think I need to share the screen. Uh, so this is the last step we are, and let us leave as it is. Let us go to chat GPT. And here I'm going to see right now, we should not do anything in this page. Why? Because this page is related to one domain that we have already discussed in our earlier session, like last class. So let us go for the new chat. So this is totally a different topic. So let us control V. So you paste this topic here and we have the values of T and Q. Okay, no problem. Just we will make AI to understand this. T is time in days and Q is production rate. Okay, so these two values we have defined it. So what with this values, with this given data, generate production decline curves, name them exponential, harmonic, and hyperbolic. So what I'm asking is, this is something beyond, uh, you know, uh, our capacity. Like in Excel, we need to keep a lot of efforts to solve either B or D or whatever it is. You can see how the data have generated and a lot of things have been done over there. So right now, I'm just asking it simply to generate with the data that we have. Okay, this is something what today industry people are doing with the current data. They're going to generate and forecast future. So let us see how AI will, whether it will help us or it will ask more information or whether it will not give me the what is that I am expecting. Okay, so our hyperbolic was generated and I want compare the uh, compare the graphs with given data and I want it to be done in one code itself. So one code Python. So let us see how it will work. Give me the code and we will see what it will happen. So it is using two libraries. One is NumPy matplotlib. It has given a code. So whatever prompts we have, let us see whether we'll get the answers for that or not. And I have to see whether the code is compiling or not also. Let me just check out the code. So it has given me the values of exponential hyper, but as we know that earlier we asked the prompts in dark image, so it is continuing with dark image. So where I can't see the earlier exponential. So for that, what we have to do is let us try to make the background style should be lighter and adjustable. Lighter, lighter is enough. That is better. This is the one the code was. But actually, okay, we'll see what will happen. It is too much light, so we need to do some changes in the code itself. Okay, starting itself, we will try to. We have to ask it to give a proper lighter. With, I think I'm getting some messages. Chat GPT is always okay. Um, Background style should be lighter with dark scatter lines. That's enough. And one more thing I would like to ask is suggest me uh, the best fit. Why? Because I want to know. Why? Because I want to know through AI itself. Suggest me the best fit curve for the given data. And I want it to compile with RSQ. Simply I'm giving it as RSQ. Let me see what answer it will be. It has using 4 libraries: NumPy, Matplotlib, SciPy, and Sklearn. Sklearn metrics. Why? Because we are using for R square, so it requires another library for that. So this is the code it has given. So let me just check out lighter and lighter. So you can see the value that it has suggested us is production decline curves, but there is no, uh, it has given the blue line. That yellow one is not at all visible. Probably it is having R square equal to same harmonic and hyperbolic. You can see the R square values here. So according to, Python, not definitely not exponential. Why? Because you can see -87, the green line, blue, I think it is far away from the original data. But when it comes to the harmonic and hyperbolic, R square values are almost same. Means like this yellow line, which is already invisible, that could be behind this gray line. That is the reason it is not visible. So I can do one more thing. I can ask it to give these graphs separately. Um, Generate all curves with given data separate. And okay, let it be. Okay. Okay. So you can see that we got all the values in a separate way. One is harmonic and hyperbolic, exponential. Of course, the line is here. So you can right now see how the curve is being fitted on the three ways. Um, we are satisfied with these results, but only thing is that background. Let me try to ask it to change the background. Um, Default background. We see whether it could change anything which is still the color is being taken as black only. The Q values. Okay, black is fine. You can change the color over here. But anyway, whenever whatever changes you are doing, don't do changes here. Only the changes you need to prompt it. Why? Because that cannot be considered by ChatGPT. Whatever changes you do, that has to be in prompt only. Still the background color was not adjusted. So for that, we need to separately start prompting in this way. So as we see over here, of course, that background is the one which is something that we have to do it once again. But apart from that, the three graphs that you are seeing over here and the one which is according to uh, Python, the best fit curve, it haven't given it, but it has given two curves which are fitting well. So we will ask it to give us what is the best fitted curve. Suggest the best fitted curve. Based on, you can see the value here, based on RSQ, R square values, the hyperbolic decline curve model has the highest RSQ value, that is 0.949, making the best fitted curve among the three models. And the same way we got it in Excel. So you can see the Excel curve, we have 0.98 and we have defined hyperbolic to be the best fit one. Here also we got the values of hyperbolic decline curve to have the best fit and the value is 0.94. Here we got 0.98. Yes, 0.98. But anyway, Python has given you the value of 94, which is, see, you can see the R square values 0 0.8, 0.93 and 0.94. So in that way, we can able to, get the help of AI. Like for Excel, creating that production decline curve could take at least, like, if you are well versed with Excel, it will take you at least 1 hour. But right now in Python, I haven't done any coding, neither I haven't given any values of parameters like B value, D value, nothing I have given, no constant values. Just I asked it to compile the values of, I have just kept the original data and I asked it what is that I want. And that too in the platform of Python. I used Python as a platform. So you can see how the results came. And I hope you understood. So this is the impact of AI on anything, but here we are talking in reservoir engineering. So we have gone through this. Thank you very much. I hope